everyone, this is Melody Rondeau, and I'm going to be walking us through the lesson Interpreting Intercepts. I believe this is on page 22 in the Algebra 1 notebook. Our learning intention for today, I'm learning to find and interpret key features of functions. So yesterday we did find, and today we're going to be doing the interpret part. Our success criteria, I can interpret the x and y intercepts given a real world situation. So here we go. Example 1. A hot air balloon is 750 meters above ground and begins to descend at a constant rate of 25 meters per minute. The function f of x equals 750 minus 25x represents the height of the hot air balloon after x minutes. Find the x and y intercepts given the graph. So if we are trying to find our x and y intercepts like we saw yesterday, we're going to look for the points where our graph crosses the x and y axes. So I'll start with the x. If I look at my graph, where the graph crosses the x-axis is right here at 30. So my x-intercept would be at 30, and to write that as an ordered pair, I put 30 in the x spot because it's an x-intercept, and the y value will be a 0. We kind of talked about that yesterday. So an x-intercept will have 0 in the y spot. And then a y-intercept, we go over to our graph, look for where the graph crosses the y-axis. It looks like it crosses right here at probably 750. So to put that into an ordered pair, that would be 0 for the x and then 750 for the y. So those are the two intercepts from the graph. Let's take a look at part B, which is in actually the next box. So part B, it's the same situation. It asks us to interpret the x and y intercepts, and I'm just going to actually quickly copy those over. The x-intercept from the previous slide, what we just saw was, I believe, 30, 0, and the y-intercept was 0, 750. So, all right, so we're supposed to interpret those. So what do those two things mean in context? Sorry, trying to update these couple little things here really quick. Okay, so we have in the problem, it actually tells us what the x represents. If we look back in the problem, it says after x minutes. Also, if we go back and look at the graph, we have the x-axis right here, and we see that the x is being represented, or time is what x is representing. So we can get that from two places, again, from the context and then also in this case from the graph. So when we interpret an x and a y intercept, we want to make sure that we have both numbers accounted for in our ordered pair. So the x represents, I'm just going to jot that down, x is time in minutes. And then our y, in this case, you could go back and look at the graph or look at just the function. So remember, y is going to be the same as saying f of x. And the y in this case represents the height of the balloon in meters. So that's important as we go ahead and interpret the x-intercept. So as I go through, the x-intercept has two numbers, 30 and 0. The 30 in the x spot represents time. So I might make a statement like this to interpret my x-intercept. After 30 minutes, and then I have to say what's happening with the y. The y value is 0, and the y representing height in meters. If the height of the hot air balloon is 0, that means it's actually sitting on the ground. So after 30 minutes, the hot air balloon is on the ground. Cool. And so if we want to be, just to make it super clear here, that this part where it says is on the ground, that's actually the part that represents the 0. This is 0 meters in height. If you wanted to write that, you could. But this way of talking about it makes a little more sense in English. We don't tend to say it's 0 meters off the ground. We would just say, oh, it's sitting on the ground. So there we go. There's our x-intercept. Then we have the y-intercept. And this one, I'm going to look at my y-intercept of 0, 750. So in this case, the 0 in the x spot represents time. So when we see 0 as a time, that means it's 0 minutes, or we haven't started counting the time yet. So it's what we would say is at the beginning. So in this case, if I go back and read my problem, it says a hot air balloon is 750 meters above ground and begins to descend. So I might say something like, when the hot air balloon begins to descend, and I can even add that little parentheses or say that 0 minutes to show that I know I'm including that 0 concept. We always have to make sure we have both numbers. All right, so when the hot air balloon begins to descend, 0 minutes, the height is, now I'm talking about the y value, so I'm going to say the height of the balloon is 750 meters. And that's essentially what we're going to look for each time we're interpreting intercepts, is basically a sentence that explains the x and the y value at that particular intercept. So one sentence for x and one sentence for y. Let's go ahead and try example 2. All right, a bank employee notices an abandoned checking account. With a balance of $360, the bank charges an $8 fee for every month the account is open. Write a function that gives the balance b of x, so I'm going to start with that, b of x, b representing balance, of the account in dollars after x months. So my x is representing time in months, and of course b of x is representing the balance or the money in the account. Okay, so the balance in the account, well, let's see, how much money does the account have? Right now it has $360, and it says the bank is charging an $8 fee. So is that $8 being added to how much we have in our account, or in that account that we found, or is it being subtracted? It should be, if the bank is charging a fee, it's actually being subtracted. So I'm going to subtract $8, and I have to do it for every month. And since our x represents time in months, I would do 8x because it's happening multiple times, not just one fee, but every month. And so that gives me my equation, or my function. Then for part B, we're going to find the x and y intercepts of the function. So even with it written in function notation, remember b of x could be rewritten as y. So if it bothers you, you could rewrite it this way as well, so that we can easily see our x and our y. All right, so to find the x-intercept, we learned yesterday that we are going to make the y value 0. So essentially, I'm going to say 0 equals 360 minus 8x. So I have to solve that for x. You have your choice of how to move things around. I might just add 8x to both sides because I just want to, like making that negative a positive, I guess. And so 0 plus 8x gives me 8x. I have 360, and then negative or minus 8x and plus 8x, that's 0. Then I would quickly divide both sides by 8, and I get x equals 45. All right, so my x-intercept, to put that into an ordered pair, would be 45, 0, the x value, and then the y value. Then I would need to find the y-intercept. To find the y-intercept, I'm going to plug in 0 for x. So I'm going to go ahead and use the y notation and say y equals 360 minus 8, and then times 0. So to simplify, this one actually not too bad, because 8 times 0 gives me 0. So I'm actually left with my answer of 360 for y. Okay, then I need to turn that into an ordered pair. So that would be 0 for x and 360 for y. All right, so I found the intercepts. Now I need to interpret them. So going back to the x-intercept, I need to make sure I include both numbers. So the 45, or the x in this case, again, represents the time in months. That's back in part A. So that means after 45 months. And then I would need to include the y, the fact that the y value there is 0. 0 for the y representing the balance on the account. So I would say the balance of the account is $0. So there's my x-intercept. Then my interpreting the y-intercept, I would be doing the 0, 360. The 0 for my x, in this case, is time. So it's at the beginning. In this case, the beginning of my situation is finding the abandoned checking account. So I might say something like, when the account is found, and again, I'm going to comment here so we can clearly see the 0, or time equals 0 months, something like that. So when the account is found at the beginning of the situation, that would be another way of saying it. Then I go to the y value. The balance is $360. And there we have it. All right, so we wrote the function, we found the x and y intercepts, and we interpreted them in context. Last one, or I'm sorry, the second half of that problem apparently. Use the intercepts to graph the function below, and I already interpreted them. Apparently I have my parts a little mixed up, so I apologize for the out of order part there, but the interpretations we just did on the last slide. All right, so part C, we can use those intercepts to graph the function below. So those intercepts, again, actually I'm going to go back because I don't remember what they were. We had 45, 0. That was our x-intercept. Don't mind that. And then we had for the y, 0, 360. That was the y-intercept. So to graph our function using just the intercepts, we would go to those points. So the x-intercept is at 45, 0. So 45 up 0. And then for the y-intercept, over 0 and then up to 360. And then once we have those points, we would do our best to connect them with a nice straight line. I'm going to do my best here. Nice straight line. Something like that. And we have graphed the function using intercepts. And I believe that is the end of our notes. So let's take a look at that. The success criteria. I can interpret the x and y intercepts given a real world situation. If you feel like you've got it, check it off. Otherwise, circle it. Check out Google Classroom for our practice assignment information, and I will see you guys later. Bye.